elasticity means material. It depends upon moment of inertia, means what is a cross section. It depends upon the material because we know what is the density and what is the cross-sectional area. So it depends only on this. And then it depends on length, how long you made. It is interesting to note that they say, I don't know, I mean, I did not check, but say one Greek colleague of mine, late Professor Dimaragonas, maintains that Pythagoras, already in 6th century before Common Era, knew that natural frequencies are inverse proportional to length squared. He did not know this formula, naturally, but he knew that when length is increased 2 times, then frequency is decreasing 4 times, which was a very interesting knowledge for that time. No differential equations, no nothing like that, and suddenly there is such a knowledge. Any other questions? Please, you have a question? Please come up with a question. Some question.
If natural frequency is bigger, like this k squared, it depends on k and square, then period is bigger, not period.
Yes, paying attention
Periods.
that there are periods. Periods are inverse proportional to frequencies. So then there are various periods here. First frequency is the smallest. Therefore, first frequency is associated with longest period. And second frequency is bigger. So therefore, period is smaller, etc. So there is infinite amount of natural frequencies. There are infinite amount of periods also. And these periods, frequencies here, first frequency is k equals 1. Second frequency is bigger. Third frequency is even bigger. So therefore, periods are opposite. First period and second period is smaller. Third period is smaller, etc. There are infinite amount of periods that go to 0 at the end. I mean, when k goes to infinity, the k's period is 1 over k squared. Your question, please? You don't have right now. Okay, the same person has a question. Yes?
Can you show the one actual system in the real world? What happened when this one happened? Like, if you have a beam and it's checking, right? If you have a beam and it's checking, something like that.
What do you mean checking?
Checking is
Vibrating. Student says, we have a beam of, and beam is vibrating. Then? Oh, you want to see such a system?
yes,
Actual illustration.
Okay, just take a guitar and just make this and it will vibrate. Or stop in my office and I'll show you a system that vibrates. It's very simple. Very simple. Any other questions? Your question.
If any frequency is met, does that mean it resonates?
Okay, if excitation coincides with one of the frequencies, we should assume that system will resonate. Yes, and that is not good. So now there are much more dangers. So we thought in 1 degree of freedom system, what we have to do is just stay away from natural frequency. But life is more complicated. In life, beams have infinite amount of frequencies. So we have to be very careful to stay away from each of the frequencies. Okay, on one hand, you may say, okay, life is a bit more dangerous than it seems. Yes, that is correct. But it also demands us to be more clever. Is it right? So we shall overcome, like song says. We shall overcome these difficulties. Any other questions? Okay, one more question.
what we have to do to make k bigger. We have to put more force. Right?
To make what bigger? Student says, what should we do to make something
To
bigger?
make k bigger.
K bigger?
K.
No, K does not have to be made bigger. You see, once we have a system, then there is infinite amount of frequencies, and we will find by this expression, by putting k equals 1, 2, 3, 4, 5, etc. Everything is here already, everything. K equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Please tell me to stop, otherwise I will continue. 11, 12, 13, 14. Okay. So here we have all the frequencies. We don't have to make k bigger. Everything is there. You still have a question, okay?
One last question.
No, I don't want last questions. I want a question. Last question, why? I want you to ask many questions.
You might be outside the scope of what's probably.
Don't worry, I will tell you if that is so.
Regarding the crystal composition as far as like crystal open, crystal coming back. Lattices,
Yes.
What are the defects?
Okay, so what happens is that a response will be a linear superposition of responses coming from various frequencies. So that will be when there is an excitation on the beam. When beam is excited, for example, this beam could be a ship in the sea. So then we see that this is actually not simply supported beam, but this beam is free on the left and free on the right. And at least from afar, from a shore, it looks like a beam, or rocket, or a car, or parts of the car, axis of the car. So these are the beams. And these beams have infinite amount of natural frequencies. Okay, these natural frequencies, naturally, some of them are very important, some of them are not important. Why? Because responses will be inverse proportional to omega squared, omega's natural frequency squared. So for bigger frequencies, probably will contribute very little. So only first several frequencies will be contributing something. But sometimes many frequencies are excited. For example, in say supersonic aircraft in turbulent air, many frequencies are excited, extremely many frequencies. So there is all these natural frequencies like are dancing in a one very huge discotheque. And we hear noises, etc. And then we should make sure that this noise will be bearable by this airplane. And it will be comfortable for me, say, as a passenger, etc., etc. So, but the main thing actually is that paying attention, also we did not touch almost anything. There are fascinating questions posed. The questions that each of you posed are fascinating questions. They demand answers, etc. By chance, it so happens that these questions that you have been asking have questions, have answers. But there could be some questions that are not answerable. For example, when this beam is treated as a nonlinear system, then until relatively recently, until just 1973, I mean, 1973 is not very far away from us, just 25 years ago, I suspect that each of us was alive. I was alive. I don't know about you, but maybe each of you was alive also. So until then, we thought that there is an order. I mean, everything will be behaving very well. Suddenly, one professor, whose name is Lawrence, passed away just past year, he found that some small differences, very, very small difference in some excitation can make a very huge difference. So he called it butterfly effect. Butterfly effect means like, that is what he said, I think, that maybe butterfly in China is making a flip with its wings, and in Florida, we are in Texas, I think he wrote, in Texas, suddenly there is a hurricane. So we have to treat butterflies in China very well, otherwise they will make hurricanes here. So this butterfly effect suddenly was discovered just in 1973. And how was it discovered? When he found results, he thought that this was a computer error. So he actually put it away. He thought, no, I have a mistake. That cannot be. When you are encountering something new, sometimes you say, maybe it's a computer mistake. Maybe it does not exist, or something like that. Several years later, for example, I read an article, but in totally different field. Lawrence worked in weather prediction. Weather prediction. So I do not read usually weather prediction papers. But say in another paper about buckling of the beam, the author wrote, and I was surprised how he could have written it, I'm getting some chaotic responses, maybe because of numerical errors. So that was even published. But it turns out that this was not numerical errors, but because that is what happens. Okay. Yes, please.
What is problem? Omega K. K in this case
Is a positive
is
integer.
from different materials, right?
No, K does not depend upon material. K is, the student asked me whether K depends on the material. No. K, because sine alpha L equals 0 means that alpha L is K times pi. K is 1, 2, 3, etc.
Oh, okay.
K does not depend upon the material. K is a positive constant. But what depends upon material is omega K. Because there is E and rho. E is modulus of elasticity, rho is density. So E over rho is material property. Now this depends upon the geometry of the cross-section, moment of inertia divided by cross-sectional area. And it also depends upon L. Yes, sir. You can ask many questions. We are not in a hurry.
What would be the main disparity between K in solid body mechanics and K in particle?
Okay, so this student is asking what is the disparity between solid body dynamics and here. So this is actually solid body dynamics. We just consider a beam. We did not consider an elastic body, a big body. What is a big body? Something that has 3 dimensions that are comparable with each other. That body is called a solid body. Here we deal with something that has predominantly long one dimension, which is a beam. And why do we deal with that? Because, first of all, there are extremely many beams around us. Say, like car, I mean, especially long car, or parts of the car, ship and building, etc., can be approximated as beams. Mathematically, they're the simplest. So it does not make sense for us to start with a system that has not just K, but say K, M, and N. So 3. If I have 3-dimensional body, then natural frequency depends upon 3 positive constants. K, M, and N. Each of them can take values from 1 to infinity. It does not make sense for me to do that because this contains all mathematics that we need. Everything that is needed is here. One question, paying attention. I allowed for many questions, and I welcomed each of the questions. But one question that is so requesting to be asked, you did not ask. Why don't you think about that question? There is one question, or at least remark, that you could have made for what we obtained, but you did not ask me. It's not, I'm not accusing you that you did not ask me, no. But it is nice to think, maybe 1 minute, what kind of additional question you could have asked that you did not ask. Yes, sir?
Did we said alpha squared, or alpha was the power of 4? We didn't necessarily derive the 4, we just said 4. Could be 6, could be 8.
Okay, no. Okay, student is asking, why did we denote rho A omega square EI alpha in force power? Okay, we did that because differential equation was in force order. And I said, because it is force order, and we will get characteristic equations, therefore it makes sense alpha to be denoted in force power. But if I would say, if I did not know, I mean, that is what literature did. But if I would have said, I don't want alpha in first power, I just want alpha. Okay, I would have put alpha, then I would have gotten fourth root from alpha, etc. But I would get the same results. It's not important how I denote. The result should be the same. Natural frequencies should be the same, because if natural frequencies depends on how I'm denoting things, then it is tragic, actually. Naturally, no. I mean, it does not depend on that. But there is one very cardinal question or topic that you did not ask. Yes?
I'm looking at omega k. Once again. What happens if we have a system that has either infinite stiffness or a stiffness that is negative?
Okay, so student is asking what happens if stiffness is infinite or large or it is small. So if it is small, then first frequency will be very small, and if it is large, then first frequency will be large. What else? Okay, the question that we did not pay attention collectively is a very interesting phenomenon. That natural frequency suddenly has pi in it. There are infinite amount of frequencies, they all depend upon pi. Despite now what is pi? Pi has to do with the ratio of the circle to the diameter. But I never said what is a cross-section here. I did not say it's a circular cross-section. It's not important whether its cross-section is circular or non-circular. There is pi here. Pi is coming. This is a surprise. This is a very big surprise that suddenly pi comes into this problem. Why in the world pi should be here? Could we have anticipated, say, if you were sent to some island, okay, and paid our expenses, etc., and just we would be told, meditate, what would be the natural frequency? Would we think that there would be pi? Each natural frequency depends on pi. Why is that? A student says that because it has to do with vibrations, that is what you mean. Because it breathes, like it goes like this and goes down, up and down, etc. So this is an explanation, but paying attention, still pi, having pi, is very surprising here.
The basic definition, omega and frequency, they are interrelated by pi.
Student is saying whether it is a definition that omega is connected with pi. No.
No, omega and f. Omega is equal to 2 pi f, right?
No. Omega equals 2 pi f, it is something else, but I don't talk about f. We don't have f. We have just omega. So why should omega have pi in it, for me personally, is a terrible surprise. For me. Now, there are some people in the world for whom that is not a surprise. So for example, there is one person at Cambridge University. His name is Professor Pilkington. Pilkington, you may want to write. He says that this appearance of pi, for example, he did not say about this equation, but appearance of pi in equations suddenly out of the blue talks about interconnectedness of the world. Everything is interconnected. Somehow pi without invitation appears to our party together with every guest. Do you remember we talked about infinite amount of guests in our party? Each guest is pi'd. Each frequency depends upon pi. So there is something, if you want magic, out there, that suddenly pi comes here in the equation. I mean, it's unbelievable. Why should pi be here? I don't understand why in the world pi should come here. There is no circle, there is no ratio. Suddenly pi is here.
The beam is clamped on both ends. Shouldn't pi?
No, beam is, no, beam is, look, imagine length equals 1 meter. So it is simply supported at 0 and it is simply supported at 1 meter. What is the connection with pi? No, I could not anticipate. I personally could not anticipate. Now, I corresponded with another professor whose name is John Horgan, Horgan, also Cambridge University. Now, why I corresponded with him? Because I did not remember who said that the world, everything is interconnected. I read it somewhere, I think in Newsweek magazine. But then I misplaced that. And I was looking. Mr. Horgan wrote many books like Theory of Everything, Theory of Nothing, Unknowability, I mean, this type of philosophical scientific books. And I saw that he is the one who said this. So I asked him, what do you think about that? So he got so-called Templeton Prize. Templeton Prize is for reconciling science and religion. I don't know whether he's a religious person or not, Professor Horgan. He writes, I mean, a lot. He has, for example, a book, Pie in the Sky, etc. So he wrote me that maybe, just maybe, because beam is not restricted, say, I asked, okay, let me change his explanation for the beam. Because this beam, so to say, is not restricted where it will vibrate, so it could vibrate like in that direction or in this direction or in this direction. So there is axial symmetry around every direction. Then suddenly directions are connected with 2 pi and pi, etc., 2 pi angle. It could go each way, this way and 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 that way. So therefore, maybe we could anticipate that pi should come up. Naturally, this explanation is good if it is worth anything, only after we have pi. Before we have pi, we don't know that it should be there. We don't know. We have no idea that pi should be there. Once we have pi, I mean, I never saw anyone to be surprised with this fact, by the way. I just went into this and checked a bit with several people. What do they think? Pi comes in many various unexpected locations in science. It will come in other places also. But this is very stunning. Okay, before we continue further, I would like to assign you homework because I don't want to be left, I do not want you to be left without a homework. And we will continue the discussion. Homework. Just one homework. This is a beam that is simply supported. W equals 0. d2w dx square equals 0. Here it is clamped. W equals 0, dw dx equals 0. The length is L. Find expressions and appropriate derivations for natural frequencies. I would say try to find. So here too, note, here too we have infinite amount of natural frequencies. But different from those of simply supported beam. What is this set number? Set 7 or 8? 7. So just one homework. I think that I'm a great teacher because I'm giving just one homework. I cannot give you 0.3 homework or 0.7 homework. So I'm giving a minimum number of homeworks. Yes, sir. Appropriate derivations for natural frequencies. But I would like you to sit on this problem. I mean, review and check, etc. But we did not finish. We have still a couple of more minutes going. We will finish this simply supported case. So k is integer means, look please, the k, this is k, 1, 2, 3, 4, etc. So that is the values of k. Omega, this red is nothing. Omega is then 1, 4, 9, 16, etc., etc. Because it's k squared. So omega is connected with k squared, omega itself. So what you can say is that natural frequencies become less and less dense at high values. They are more and more far apart. Look please, here 149, then 16, 25, 36, 49, 64, etc., etc. They are farther and farther apart. Density of frequencies is decreasing at high frequencies. Density is decreasing. Okay, we will finish here and we will continue next time, unless we have a question. Do you have any questions? Say it again. Oh, then I will do it later. I do not have this planned, to talk about this. Thank you very much. I did this long discussion, by the way, for you deliberately. In order to imitate. Yes, thank you so much. I'm not taking this with me.
You're not?
Because then I have to return. Then it takes too much